Welcome everybody. It's 9.6 System of Equations word problem. So we're taking the same thing we learned, solving systems by elimination, and we're going to apply it to word problems. Okay, solving systems, and then we're going to construct linear functions. So we're going to create a system of equations given a word problem, solve a system of equations, and apply it to a word problem. So first one, I'm thinking of two numbers whose sum is 30. Two numbers, sum is 30, and difference is 10. What are the two numbers? And can this riddle be solved using a system of equations? So I'm thinking of two numbers whose sum, right? Sum is addition. So we have two numbers, let's say x and y, and they add to 30, right? So two numbers that add to 30. And a difference, remember difference is subtraction. So x minus y equals 10, right? So that's a difference. So now we have a system and we can easily solve this, right? Because we want to eliminate these y's. So when we add them, they're just going to eliminate. So x plus x is 2x plus y minus y cancels out. 30 plus 10, 40, right? So we have 2x equals 40. Then just divide by 2. To detach the 2, we get 40 divided by 2, 20. So x equals 20, and then we can take that and find the other number using either equation, right? Our x is 20, put it in there. So we have 20 plus y equals 30. Subtract 20, and we can see that y is 10. Right, so our two numbers, 20 plus 10 is 30, 20 minus 10 is 10. All right, so that's solving a system using a word problem. Okay, second, find two numbers whose sum is 64 and whose difference is 42. So two numbers again. So sum is 64, difference is 42. Same thing, right? Now we can just add to eliminate right here. Set up perfect. So our y's are going to cancel. So we get 2x plus 0 equals 64 plus 42 is 106. Divide by 2. X equals 53. And we take that, put it into either equation. Right, take our 53, put it in for x. So we have 53 plus y equals 64. And just solve for y. Subtract 53. Y is equal to, so 63 minus 53, or 64 minus 53, 11. So y is 11. See, that works. So 2 now, 53 plus 11 is 64. 53 minus 11 is 42. So that works too. Okay, let's apply it to word problems there. So basketball. In an NBA game last season, Stephen Curry and Golden State Warriors made a total of 21 baskets. So 21 baskets. All of the baskets he made were either 2-point baskets or 3-point baskets. He did not make any free throws. He scored a total of 49 points. How many of each type of basket did he make? So just like the problems before, if you have two numbers that add up to something, right? So we have baskets that add up to 21. So when we do a total number of baskets made, so different colors here. So total number of baskets made is going to be equal to 21. Right? And you either make 2-point baskets or 3-point baskets. So let's make X 2-point, Y 3-point. Right here. So 2-point is X, 3-point is Y. So total amount of baskets, right? 2 points and 3 points equals 21. So get total points scored in a game. So total points was 49. So it's going to be equal to 49. And total points, right? You get 2 points for each 2-point basket, 3 points for each 3-point basket. Right? So when you write it out, you have 2 times the number of 2-point baskets will give you your points for 2-pointers, plus 3 times the number of 3-point baskets will give you 3-pointers. And you add those together, you get total amount of points, which is 49. So we have our system here, x plus y, because total baskets, 2s and 3s, total 21. And then you have a different types of baskets, 2-pointers and 3-pointers give you a total points of 49. So now we have a system that we can solve. Right? So again, we don't know what it was. So let's cross multiply. Right? We could multiply top equation by 1 or 2. Right there, 2. This one will just be 1, right? So we're going to have to do anything to it. So we can multiply top equation, and they're both the same sign though. Right? They're both positive. So I have to make one of them negative. So we have negative 2x, negative 2y, and negative 2 times 21, negative 42. The bottom equation just comes over. Now we can add to eliminate. Right? Your x is going to cancel out. So negative 2y plus 3y is just 1y. Negative 42 plus 49 is 7. So y equals 7. And then we can use that 7 into either equation. Let's use the first one. So y is 7. We put that in for y. So we get x plus 7 equals 21. Subtract 7 both sides. We get x is equal to 14. So x is 14, y is 7. Right, and what does that mean? So remember, x is your 2-point baskets, right? 2-point baskets. So if x is 14, so he made 14 2-point baskets. And your y's is 3-point baskets, right? So 7 3-point baskets. There. And that's our answer. So we make 14 2-pointers, 7 3-pointers. He's on fire. Okay, number 2. Okay, Mary Stefan, each planting daily geraniums. They bought the spot at the same store. Mary spent $14 on 2 daylilies, 2 geraniums. Stefan spent $19, 3 daylilies, 2 geraniums. And we're going to make our columns, right? Remember our word columns, make columns. Right, so we have our daylilies, let's call them days, and then geraniums and money. So the first one, $14. And 2 daylilies, let's make it x, 2x, plus 2 geraniums equals that $14. Second one was $19, 3 daylilies, 2 geraniums. So now we have a system and we can solve that. All right, and we want to eliminate, let's eliminate these y's here because we just got to multiply one of them by negative. All right, so this is multiply top equation by negative 1. All right, so that becomes negative 2x, negative 2y, negative 14. Bottom equation just comes over right there. right? And now we're going to eliminate. So negative 2x plus 3x, 1x. These cancel. Negative 14 plus 19, 5. So x equals 5. Right? And you notice we could eliminate the x's if we wanted to by cross multiplying and make one of them negative. We could do that. So you have options. Or you could limit the y's and multiply one of them by negative 1. Up to you, whatever's easier for you, how you want to do it. We're going to end up at the same answer anyway. Okay, then we take that x equals 5, we're going to put it to either equation. Let's use the first one. 2x plus 2y equals 14. So we take that 5, put it in for x, right? So 2. Now we got 5 in there. And now we solve as usual, right? 2 times 5, 10. 2y equals 14. Then we solve. Get rid of our 10 friends. First, we get 2y equals 14 minus 10, 4. Divide by 2. Y is equal to 2. So our x was geranium, was daylilies, right? So we just gotta remember that. Our x value was daylilies. So when we answer our daylilies, and then what is the cost of one daily, one geranium? So daylilies are gonna be $5. Geraniums, which is your Y's, right? So our Y columns is geraniums, so that's $2. So make sure we matching up what we got. So if our X is 5, we match it up with the X column, which is daylilies. If our Y is 2, we match that with our Y column, which is geraniums. Okay, number 3. Okay, school at JD goes. Sending tickets to a play. First day tickets sold, 7 senior tickets, 7 child tickets, total $91. Second day, $83, 5 senior tickets, 7 child tickets. Find the price. Okay, again, we set up our categories, right? We got senior, we got child, and we got money. So first day, 7 seniors plus 7 child, $91, right? 7 seniors, 7 child, $91. Then we go to our next one, $83, that's our money, for 5 senior tickets plus 7 child tickets equals $83. And now we have a system that we can solve. Okay, so let's try to get rid of the x's now. So we did our x's, we noticed that 7 and 5 are not easily matchable, right? So we can cross multiply it. So we can do that, cross multiply. So 5, 7. And since both are positive, we need one of them to be negative. Let's make the top one negative. Right, so we distribute here. You could, if you want to eliminate the y's, you could do that too. I'm just doing this for an example. If you don't see this here, you can just cross multiply. So negative 5 times 7x, negative 35x. Negative 5 times 7y, negative 35y. Negative 5 times 91, $455. Negative 455. And then distribute the 7, 35x, 49y, 83. So 7 times 83, 581. Then we add to eliminate, right? Our x is going to cancel out. We're left with negative 35y plus 49y. It's going to be 14y equals negative 455 plus 581. All right, that's going to be 126. 126. Then we divide by 14. Y is equal to 9. Right there. So y is 9. And then we use that. We find what is the x is, right? And we use either equation, whatever we want to use. Let's use the second one this time. So 5x plus 7y equals 83. Our y's is 9. Put that in there. Put that in right there. So we have 5x plus 7 times 9 equals 83. So we have 5x plus 63 equals 83. 7 times 9 is 63. And then subtract 63. Both sides, we have 5x equals 20. Divide by 5. And we get x equal to 4. Okay, and then once again, remember what we're writing in here. So we know x is 4 right here, senior column. So our seniors is $4. Then we look at our y's, which is our child column. So our child is $9. That's it. All right, so we're just setting up our categories in columns, set up our system, and then we solve our system as usual, like we've been practicing. And then make sure when your answer, your X numbers match up with your X column, whatever units or category that is, right? Senior tickets, $4. Y's match up with your Y column, which is child, so that's $9.